Hello and welcome to CalmCar video. Today we will discuss how to benchmark a vehicle vision system. For those who don't know CalmCar, we are an innovative AI company specialized in vehicle vision sensors for ADAS and autonomous driving applications. We supply not only the mass production vehicle vision products to those automotive tier 1 suppliers or OEMs, but also the engineering services to help them test, validate, and benchmark various vehicle vision systems available in the market. During our project work with many Tier 1 and OEMs who have already integrated the ADAS functions in their vehicle products, we found out that one of the biggest challenges is about how to objectively evaluate the ADAS function performance. We want to know how well the individual sensors are performing in the real world, which is the prerequisite for delivering the satisfactory ADAS functions. For example, if the lane departure warning function doesn't correlate well with driver's human perception, we want to know how the camera was seeing the actual landmarks on the highway and what was the difference between machine's view and a human's view at that particular time. In today's video, we will discuss two effective technical solutions to address this challenge. Solution number one is so-called road performance restoration. Assuming you have been using a forward-facing camera from a renowned vehicle vision company, let's call it camera A. The problem is that the camera A is such an integrated piece which only outputs the sensing results, and they are the only information you can store in your vehicle data acquisition device. As the ADAS development engineer, I need to know how well this camera detected objects. Did the camera classify the objects correctly? Was the pedestrian detection responsive enough? And how robust was the lane detection, etc.? All these questions cannot be answered if you have only the CAN output without the restoration of the actual raw ground truth images. To fill this gap, we will put the CalmCar front view camera, let's call it camera B, next to camera A, which is installed on the vehicle windshield. The camera B will then record the raw ground truth image and store them locally on the in-vehicle data acquisition device. At the same time, the CAN output data from the camera A will be synchronously transferred and stored to the data acquisition device too. So when you bring the data back to the office, the ADAS development engineer is able to use CalmCar's proprietary benchmark software to overlay the sensing results from camera A to the images which were recorded by camera B. Now let's take a close look at how the CalmCar benchmark software works. Before we launch the benchmark software tool, let's go over the data we have just brought from the vehicle back to the office. In this folder, we have seen two data sets. One is the raw video data recorded by camera B, and the other one is the CAN output file we received from camera A. Now let's launch the CalmCar benchmark application. Maximize the window. So the first step is to load the raw video data coming from camera B. So I'm loading here camera B raw ground truth EMP4 file. We can click on the play button to check if the data is in good quality. This looks good to me. So the next step is to load the CAN output data from camera A into the software. We need to select Load SIL1. So it will show you that you can select the camera A output CAN.blf file. Okay, because of the synchronization mechanism used during the data recording phase, the CAN output file will be automatically associated and merged with the raw video data, even they were not coming from the same sources. To display the merged data, you can use the drop-down menu and select CO1 Now you can see that the CAN output file is overlaid on the raw video data that is collected by camera B. Just imagine if you have two different versions of detection algorithms, and you wanted to check what is the performance differences between these algorithms. So you can collect it two different times of that CAN output files, and using that CAN output files associated with the same raw video data, and it displayed in two windows. So you can choose two channels here and load the CAN output file 1 and CAN output file number 2. So in that manner, you will be able to see that two different kinds of detection algorithms, how they are associated with the raw image and what were the performance differences, even they were used at the same scenario. The second solution is so-called road performance KPI. This is actually the similar approach as solution 1, but with adding the perfect labeled ground truth to be used as the reference for KPI calculation. The primary difference comparing to solution 1 is that we enabled the AI algorithm inside the CalmCar vision system, which means that the camera B is not only recording the raw video data, but also perform the sensing tasks by executing the CalmCar's own AI algorithms. The raw image data will be automatically annotated, followed by the manual adjustment to reach its highest accuracy level. This version can be called as reference labeled ground truth. The KPI calculation is based on the comparison of the camera A's performance against these reference results. Now we are back to the CalmCar benchmark software 2. We are about to load the reference labeled ground truth in the form of a bin file to be overlaid to the same raw video data. So we go to the file menu, load the bin 1, and we are loading here the CalmCar labeled ground truth. Open it. So the next step is that we can switch the mode from one channel to two channel. The idea is on the left hand side, we can display the actual performance of the camera A, and the right hand side is the labeled ground truth, which is the reference. If you click on the play button, you will see that the difference between these two results. You can see the left hand side, the actual performance, the detected, the land is a little bit drifted from the actual landmarks on the road, and also the detection of the objects is not as good as the right hand side. So the KPI calculation will be done also accordingly in the final reports.